All right, we're going to begin Unit 6 by doing a lesson on direct, inverse, and joint variations. This is where you look at data and you see if there's a relationship between them. If data varies directly, then that means that the one thing you're looking at is directly affected by the other thing. For example, you guys, a lot of you are working. The more hours you work, the more money you're going to get paid. So your paycheck is directly related to the number of hours you work. And it has a constant variation, and we call that constant K. So in the formula y equals kx that you see over here, this K represents just a constant. It's not a variable, it doesn't change. Now y and x are the variables that change. It could go up, or you could also have a negative constant. So just know that they can go either way. The main thing you need to remember about direct variations is direct variations have got to meet at the origin. Okay, that is a necessity. Now the slope of the line doesn't matter, but it does have to be a linear function that goes through the origin. All right. So you'll notice if you think of this as the y equals mx plus b, there will not be a constant being added to it because it's always got to be plus 0. The other type of variations that we look at are inverse variations. And with that, you could say y varies inversely to x. And the formula for that is y equals k divided by x, where when one thing increases, the other thing decreases. So if you take what science has been proving lately, the more you smoke, so that one's increasing, the less number of years people live. So one thing increases, the other thing decreases. That's an inverse variation. And that actually graphs as a rational function right here. And then the other type is called a joint variation, and that's when you start working with multiple things at once. There is still that constant, so this one would be like y varies jointly with the product of x and z. You can have joint variations where you say y varies jointly with x squared and the square root of z. And so joint variations, those formulas change a little bit different, but it is when you start combining more than just one variable into the problem. All right, so those are our formulas. I have it set up so that you can solve for k as the first formula. And then if you're just looking at just a bunch of data and you're trying to predict future outcomes according to the type of variation, you might want to use this other one. All right, so the first thing you have to do is to identify if something is a direct, inverse, or joint variation, or it might be neither. What you want to do is you always want to solve the equation for y and see if it looks like the direct formula was y equals kx. The inverse formula was y equals k divided by x. And the joint is when you start working with multiple things. Okay, so if you took example 1 and you solved it for y, we're going to divide each side by x, and you're going to get y equals 3 over x. Well, that would be an inverse variation, where your constant is 3. Okay. This one here, y equals x plus 6, this plus 6 here, that keeps it from being a direct variation, so this would actually be neither. This one, 4x equals y, that is set up for a direct variation, y equals 4x. And your constant would be 4. Y equals 2 over x, that is an inverse variation, because you've got that division going on there, and your k here would be 2. And you got to make sure it's 2 over x. If you had x over 2, the constant has to be the numerator. So if you had x over 2, that would be neither. All right, and this one looks to be a joint variation where your k is 7. And that one would read something like y varies jointly with x and the cube of z. Is how you would might see that problem worded. All right, so this is just identifying, looking at a formula or looking at a problem, matching it up with its appropriate formula, and seeing if it actually does vary directly, inversely, or jointly. And always remember, neither is an option as well. Okay, so let's look at some actual problems. If x and y vary inversely, so if they vary inversely, that key word right there should get you with the y equals k over x. So it says, and y is 10 when x is 2. So this is your first set of information. Then you can say 10 equals k over 2, which means our k is 20. Then they ask you to find x when y is 5. So we're going to take the same formula, y equals k over x, except now we know y, we know k, and we're looking for x. And so with that, you would say x equals 20 over 5. So x must be 4. Okay, so you can work through it where you find k and then start back over, plug k in. Or if you look at that formula sheet, I gave you the second formula, and you could just set it up where you say xy equals xy. So you have 2 times 10 equals x times 5. Divide by 5. And when you do that, you're going to get 4 equals x. Either way, you get the same answer. It's a personal preference whether you just want to stick with the one formula that you have to know, and that'll cut down on the memorization. But you can see there's a couple more steps involved with doing it that way, or taking on the memorization of the second formula, but then making it a little easier to find that missing value. All right, the next one says y varies directly to x. So this is a direct variation. So I'm going to get my formula y equals kx. All right, I know in the first scenario that y is 10 when x is 2. So I'm going to plug in the 10 here and the 2 here. Divide each side by 2. And I get k equals 5. So if you notice, I'm doing examples using the same numbers, but just by changing the way they vary, my k becomes a different value. When they vary inversely, the k went to 20, but when it was a direct variation, the k is 5. So making sure you're using the right formula at the right time will make a big difference in you getting these correct or not. All right, so I'm going to stay with my y equals kx formula. And I want to find x when y is 5. And I know k is 5 because I just found that. And when I work this out, I get x equals 1. Or, if you choose, you may switch over to the other formula and say y over x equals y over x. And you know 10 over 2 is equal to 5 over x. Cross multiply, you get 10x equals 10. And you can solve it that way, and you should get the same answer. So either way, you're going to get the same answer. All right, let's look at our last example. If y varies jointly to x and the square root of z. So the way we would set this up is y varies, drop your constant in there, and it's with x and the square root of z. So this is the formula I would use. I need to figure out what my k is, so I'm going to plug 27 in for y. I need to solve for k. X is 3, and z is the square root of 9. So when I solve for this, I get 3 equals k. So I'm going to take that k value, I'm going to go back to the same formula, x square root of z. I need to fill in I'm looking for y. I just found my k is 3. Now my x is 7 and my z is 25. So the square root of 25 is 5. 5 times 7 is 35. And 35 times 3 is 105. So my answer to this one would be 105. So every problem is going to state the type of variation it is. It's going to give you a little bit of data, and it's going to ask you to use that data to find the rest of it. So go ahead and work on the classwork for this and see how you do.